Hey, Andrew. Your mic is off. Hey, Prayus. Hey, Andrew.
Hey, Andrew.
Hey, Rudy. So Roger was joining just now. He seemed to drop off. Hey, Jesus. Hey, Roger. Now you're back.
Hi, Jameson. Yeah,
Hey.
my computer has the communication issue. Yeah, recently. Yeah.
Yeah, I'm not surprised.
Hey guys.
Hey, Tony.
Hello, everybody. Launch here.
Hey. Let me quickly share my screen and see what we have from last time. Yeah, so I think from previous meeting, we have the agenda listed. I think like we going to 2 weeks ago we create a use cases tab, and we going to I have added like the a lot of use cases from I think one of the document I think I mentioned that we white paper that we have been working on in the CDS group, or separate groups on that. So I think that's a good information that from there we extract the use cases information from there. I think and including many material informations that related to different stages for the chiplet integration, which like many of them relevant to a 3D and 2.5D here. So like we put into that specific tab here, and then we also expanding that I think to with this information use case, and then the description, and then input output personas, and then we can expand that with material informations, and then I think Andrew kind of like expanded that with merging the material properties that he has from a separate tab here. I think by including some new columns like the analysis and the material properties here, and we're going to review this. I think say we go from there, and then the next one I think see module here, but we will be follow with module regarding bonding related material properties. We don't see Jen here. Last time we talked about we should get some test cases. We need to follow up on that, and then same as for Mike as well. But let's start with this, the spreadsheet that we have here. So I think like we did expanded quite a little bit. I think last time, especially from Andrew, I expanded, 2 columns. Here, I added, additional information on the analysis by looking into that documents and some additional research information. Andrew, you want to maybe share what you have added? And before that, that's kind of the agenda that we're going to have today. If anything else, let me know. Then then we can kind of adding anything else that we should be discussing here. Hi, Andrew, are you?
Yep. Sorry, just unmuting myself. Yeah, I didn't do a lot really. All I did was that we had this analysis column, which had was a mixture of things. So I know we had the materials properties column, which was a mixture of properties and a mixture of the materials. So I just separated those out. So one has the properties, one has the materials. I added an analysis column really to try to highlight what simulations were being run at that point. And then you can link back to the material properties for simulation tab and just copy the material properties from there. So for instance, for the thermal, I'd said that, that we probably want to do steady state and transient thermal analysis, and that gives you those 4 properties there. I see someone's put extra things in blue.
Yes, I did that. I'm just kind of thought about some of these things that I thought maybe should be there. I'm not sure, that's why I could improve. Something that we can talk about.
Yeah, so that's all I've done really. I don't know. As I keep saying, I don't know these. I don't know this kind of this domain very well. So I think what it needs is someone who really knows what kind of simulation is being done, just to highlight, because I just pulled it out of the text that was in the description column to really confirm what type of simulation are required for those steps. And then, once we know that, we can then finalize the material properties, because it's, as far as I believe, that we're focusing on the properties you need for those simulation steps.
Are you comfortable completing that, James? Or...
Come again, Tony, your question I say about in this format?
On the analysis, are you comfortable completing the rest of the types of analysis?
You mean the blue one, or for the other section? For
the other sections, yeah.
Yeah, I think that's why we kind of working on that. Some of them, they're kind of very similar. They're kind of similar information that we use on various stages, such as the material properties that used in selection, right, and the choice in the thermal as well. So I think somewhat they're repeating, but others, we're trying to. We're trying to add many as we can, and then we will use this group as a feedback and see there more insight from this group. In general, yes, we should able to trying to achieving. Information the way that we put in here.
Yeah, I'm wondering if we also need to have specific tool names as a separate field. Because some of the models may be specific to a certain tool, right?
Yeah, I think that's a good idea. I think the goal is trying to extract as many information that will be useful, right, for all this analysis. If some tools require this information for this kind of material rate analysis, I think that will be useful here. I think that's
well, yeah. I think the point I'm trying to make is a couple meetings ago, we determined that some of the models that require parameters have custom models, right? And those models are likely tool dependent.
I see. Yeah, we do have models here.
And if we do have a model that is, kind of a custom model, but it supports, 2 or 3 different tools, we can, I think we need to show what tools support which models.
Okay, so maybe
at some point. I mean, we don't have to do that now, but I think we should just, as we start building this out, I think we're going to have to do that. It's not as simple as kind of like design rules where some of the stuff, unfortunately, is going to be tool specific.
yes, that makes sense. So like, we do talk about sometimes, but we do have a specific models for that. Should we have a separate column for two as well, or should that be together, or maybe separate column for tools? That makes sense. Then is that correct?
Well, yeah. I mean, if it's generic, then it would be all tools. So I'm thinking maybe it's more like list a bunch of tools and just have a checkbox. So when we have the model, we can say, indicate which tools support that model and set of parameters.
Okay, that makes sense. Then I think we're going to start listing tools here and then see what are the models.
Yeah, I mean, just put the field in there. We can fill out
Yeah.
that later, but I think we just need to identify the analysis, and then we can ask the different vendors to plug in their tools. And
Right, let's put up on this one. And that makes sense. Yeah.
Yeah.
Okay.
Yeah.
So
James,
yeah.
did you say that you're the one that added the blue writing?
Yes, I did. I'm the one
Yeah.
adding the blue writing.
Okay.
Yeah.
Yeah, because well, certainly in this one here, I mean, you've got glass transition temperature measured by DSC and TGA. That's true, but but when I say analysis, I can already mean the simulation. Maybe I should have been a bit clearer there. So those are actually test methods that you would use to measure glass transition temperature. So that's not really an analysis. Well, I mean, it's not used for simulation. So it's like glass transition temperature is not really used for thermal simulations anyway. You generally use it in mechanical simulations.
But does this cover here? I think some of this thing. The point we're trying to. I think some of the models and material information might be reused in many places, right? Or even some of the models, right? So I'm just added there. I think if you think that is covered, I think whatever that the properties cover that you need to be in the glass transition temperatures. I think that should be sufficient, right? I think right or that's going to be more. If not, then we might have to kind of no, I think if there's any additional material information that might be needed here. I think that's why we're doing this analysis for. A lot of time they probably reuse the same information already used in other models and tools, right?
I'm confused. I thought analysis was specifying the type of analysis that's being done: signal integrity, power integrity, thermal stress.
Yes,
that's what I thought.
That's what the intention was.
Yeah. Oh, yeah. That's the intention. I think I
don't understand the comment with class. I mean, we may need to add notes someplace, but that doesn't. I mean, that seems like a very.
Oh yeah. Okay. Let me change that. I think I'm just kind of maybe do something more kind of some sort of analysis, right? Yeah, I think I maybe analysis to find out what the transition temperature is, something like that one, right?
Yeah, I think we're kind of cluttering this field, so either add a note or just a separate.
Sure. Yeah, I mean, if we're trying to make a comment here, I think but let me take that out there. I think I just put that separately here.
Yeah, this.
For now.
Well, yeah, but I'm not even. So I'm not sure that glass transition is done at this stage. I mean, a thermal is you're trying to find out what, you know, how hot things get basically, and and glass transition temperature is not really anything to do with that. Glass transition temperature is when the material kind of goes through a change, and that's normally impacted on its mechanical properties.
Right, you're right. Actually, sure, we can put that here. Right.
So I mean,
Mhm.
that actually belongs further down, but kind of Tony's right. That it kind of needs to go probably more in the material properties column. That's where that kind of information goes, because we're trying to keep a clear link between, but this is the simulation you do at this stage. Therefore, these are the material properties that you would need to support that simulation. Now, there might be other properties you need in addition, which are not used in the simulation, but whoever's, running this particular, is responsible for that step may need.
Right.
But that's not the analysis, So I think that the comments you made need to go into the material properties, but maybe we need one set of properties which are used in the simulation, and then another set of properties which are used for additional information, but are not particularly used within the simulation.
Yeah, I think you're right. I think there could be, I think we run some routing here. I think like the analysis could be more than one here, right? So we could have multiple column here. And then do a different kind of simulation or different analysis, and then you have different set of the properties for that one, right?
So Andrew, you mean like different information and maybe different settings that are required to actually do the analysis?
Yeah, I think I have different properties for that one, right? Just like kind of addition one, right?
Because
Well,
I don't.
I mean, that when you are, running a simulation, then that simulation needs a very specific set of material properties. But there might be extra information that, extra material information that you may not use within the simulation, but it's still useful to have.
I see. Okay.
So, so like glass transition temperature, it can be used in some of the electrical reliability simulations. I know that, Sherlock uses it, but for thermal simulation, you wouldn't use glass transition temperature, but it might be a useful piece of information to have for the thermal engineer, but he wouldn't be using it in his simulation.
All right, so maybe we just kind of have the provisions just to put any additional information, but it's not a material property per se.
Yeah, I mean, I just, are we just purely going for the properties which are needed for the simulation, or are we also adding additional things that might be useful?
Well, I think just XML, we're defining what needs to be in there, but you can always add additional information, and it's up to the end user whether or not they use that, right? I mean, XML experts on the phone here. I mean, you can always add stuff, right? And if the tools or the scripts don't understand it, they just ignore it.
We definitely can do that. So, right, if having said, I think I saw something sounds like additional properties or something like that.
Right. So,
yeah.
Or just additional information, right? It can be any information.
So, like, having Andrew, like having different kind of like the multiple column under, I think we run some around under this material, right? I kind of put some of this thing together, like maybe having a multiple analysis under kind of like thermal material, for example, here. And then that having separated that might help, right? Kind of give me more details, I think what property needed, and then maybe what tools and model might be needed for each of them, right? We can kind of further breaking down on that.
Yeah, I mean, just to be clear about when we say analysis, we normally mean simulation. So
Yeah.
DSC and TGAs, those are test methods. So that's how you measure glass transition temperature. It's not an analysis.
Yeah, I think analysis should just state what type of simulation we're doing.
Yeah, so maybe just make that explicit, because I guess analysis is a broad term.
Yeah.
So it's more simulation rather than just a general analysis.
That was the intention.
Mm.
Yeah, I know a lot of the thermal guys like to call it simulation. I like to call it analysis. So it depends on.
Yeah.
So I think they're probably interchangeable, analysis / simulation. But if we clearly articulate thermal, mechanical stress, you know, signal integrity, I think it should be obvious.
Right.
Right. So what, I mean, just scroll down a little bit. I'm sure you have the other, I mean, you have thermal, right? Power integrity, mechanical. Yeah, mechanical, we probably need to articulate that because there's lots of different types of mechanical.
Yeah, I'm trying to expand that. That's why I'm kind of adding more information. Also adding like chemical and electrical. I'm not sure I put in there if we want to cover those things or not. Electrical maybe because I dielectric.
Is this the related to the macro micro analysis that we talked about?
Yeah,
the
I think
micro analysis, you're actually doing kind of, you know, molecular type simulations to simulate to determine what the material property is. And we agreed that's not within the scope of what we're trying to do here. So it's just the modeling properties once that material has been characterized, because that's getting way out of you know, beyond what we want to accomplish here.
And just, you know, that again, you know, because this line here is the material property specification. So this is an input. So this is a list of kind of like extra properties you might need. So again, that should probably go in column I. I think further down I had put structural simulation on, or if you so I'd put structural simulation, which could be linear elastic, non-linear, or thermomechanical.
Okay, yeah, so that's more what I was expecting.
Yeah, and then for reliability analysis, you generally add failure to that.
Now the question is, you've got like for that structural there, you've got 3 different kinds. Should that really be 3 separate, you know, lines?
Yeah, it could be. It could be,
right.
yeah.
Because that's 3 different analysis, and they may have 3 different, you know, sets of parameters. And
right.
Yeah, we could split those up, and so I can take that as a task just to go through.
Yeah,
that's fine. I can split those up.
Right. I just want to make an example. Yeah. Go ahead.
Yeah. Thanks. Yep. So I can do that, and then I think did we have an electrical one? I don't think because again, you know, that I couldn't see where it was explicitly mentioned, an electrical
Right, that's what I'm trying adding here, but I haven't found that. We probably need to add another column for that there. Another row
Wasn't
for
there? I think was there a power integrity, or was there?
power.
There
We
should-
don't.
If you scroll further up, oh yeah, power integrity.
Yeah.
Yeah. So
Yeah.
yeah. So this is the one I didn't know. You know, I don't know a lot about that. So if someone could maybe.
Yeah, we've got John. John, you comfortable enough with power integrity? Comment
Yeah,
on this.
yeah, definitely, Tony. I can take a look at that.
So shall we have the signal integrity here? I think that will include some of the electrical, right?
Yes.
Okay. Do one thing here. View freeze one column. So I can make things here. Power integrity. Okay. Sorry. Then we have I'm going
Yeah,
to
and I didn't
test.
see that. I didn't see the thing about the model, so I can add the models in there as well. And that's, as Tony said, that's when we'd bring in the vendor specific.
Which one? Sorry, which one you mentioned? I missed.
Yeah, when I was filling this in, I didn't realize that there was an additional models column. So when it comes down to the mechanical simulation and you get to nonlinear and failure, that's where the specific models comes in. So I will add to that column as well.
Model. Which one you mean? So I missed that. We're talking
Yeah,
about
models, column K.
Oh, the models. Yes, got it. Yes, yes, there's a model here. And then, do you think we should also have these parameters here? I saw we have that parameters. That's what I'm adding here. So we have that, or maybe.
Well, I think, yeah, I'd kind of kept it in here. So if you want to look up more about that simulation, those properties, you go here rather than having to copy everything into the
I see. Okay. All right. Yeah. Let's go back that. Is that okay? Everyone makes sense, or shall we combine them, or shall we separate that? Keep that way. I think we can keep that way for now. If we need to add that, we can reconsider later. Right now, maybe we can just kind of go over that is kind of detailed information. I think that we can start with this kind of high level. I think once we have most of this information, then we can kind of look into more details here. Maybe Andrew, since you're working on this one, you can also add some of the models and also the tools, right? Whatever they maybe insist to have some specific requirement there, something that maybe you can also
yeah, I can add a few examples.
Yeah. I think that's good. I think like this John can also look into it, right? For this the SI and PI.
Yeah, James.
I appreciate that. All right. So we cover everything from your side, Andrew?
Yeah, I think that's it.
Okay. You mentioned something about the electrical, right? So I think I'll probably add some electrical information, especially maybe under like SI. Is this something that you will need to add something on it, or?
Yeah, if somebody knows about signal integrity, then Yeah, that should be added there.
Okay.
John's our resident expert.
Right. Okay, that's good. We have Roger here. I think I wrote mechanical part out from Roger and packaging side. Roger, do you have any comment? Anything like we took Roger, we took a lot of information from that white paper, right? Which I think you Lee Hong and you helped to write that. I think especially on that mechanical sections. So the mechanical analysis here, right? So pretty much there's an input output table here, right? That's what we talk here. And do you think what cover here is sufficient? Do you think anything additional that you think shall be needed? I think from especially I think from the assembly side, right? The material information.
You mentioned information from assembly for the mechanical portion.
Yes.
I check the content. I think the Lee Hong just showed what's the model and what's the procedure and the flow in the update. But actually, I think it's not unsuitable. It's not unsuitable to use the customer real device to update this. So I need to discuss with the Lee Hong again. And so far, and we had discussed this portion, and she's under the business trip. Yeah, maybe come back tomorrow. I can discuss with her again tomorrow.
I see. So you mean that you have to discuss it and see if you can put in some information here or what should be put in here or
yeah. We try to find a suitable update to revise our portion or add the content due to for example for the simulation you must have the one device then run the model to check the mechanical performance, and the simulation maybe the YBG and the stress, but you need to have the real case to run it, right?
Right.
Yeah.
Stress right. And then more important, I think from those kind of simulation that you're running there, right? I think and the assembly side, I think what we're trying to find out here, right, is trying to define what are the material information that are needed for those tools. Right? Sometimes you probably don't need in details what are those tools does and things like that. But I think it will be helpful. I think to know what material information will be needed, right, for some analysis there. I think we should try to cover in this standard format, so that when information are passed to assembly with this standard format data, they are all information available for the tools to be able to do simulation there.
Yeah, got it. Let me discuss with Lee Hong again. Due to I discussed this with her last week. Yeah, but it's under business trip. Yeah.
Understood. Yeah. Yeah, Insus, you are here. Last time I think we talked about a few people that can help with some of the volunteer work here. Or I think not Insus, Andrea actually. Sorry about that. Or anyone, right? I think the can help. I think I contribute on this. That would be very helpful there. And Rudy, do you know any tools from Cadence that might be helpful here for some simulation that require material information?
I'm looking at it. I'll have to look at it offline, but yeah, I think a lot of it lines up, and we're going to need the same things as everybody else. So there's nothing unique.
Okay, yeah. If you find anything that you need, or even though there, I think if you can just list it, I think under the tools that might be helpful. I think to help in look into that might potential material might be needed for those tools.
Okay.
Estimation those tools.
Yeah. And I guess we're going to do that just so the EDA companies are together. We'll just list existing or announced tools that are available publicly, correct?
Yeah,
That way
I think
nobody's disclosing anything.
Right.
All right. Okay. As we've done before. I just want to confirm, Tony. That was it.
Yep.
All right. Okay. I mean, it's all stuff that's on both organizations' website. So fair enough. Thank you.
yes, appreciate that. And David, you are here. You are kind of have role experience on the thermal and power side. I think especially thermal side. Do you think what cover here is sufficient here? I think based on white paper that we have, I think I took a lot of material from you have on the white paper. So do you think anything information that should be included here, especially related to the material properties?
No, this is good. Yeah, I've been quietly following this, but this is good. There's nothing special that we need beyond this.
Okay, that sounds good. Yeah, and especially I think if your tools, I think that you have the I think the trust systems or the more I think that maybe use some of the actual properties information that
Yes.
Yeah, can be included here as well.
Yeah.
So we can cover them.
Yeah.
Okay, that's good. Appreciate that.
What about self-heating? Is that a different type of analysis that we should include?
Self-heating?
Self-heating.
Self-heating.
Yeah, I know that at the IC level, it's a type of analysis.
So it should be under the material here, right? The self-heating.
Well, I'm just asking if anybody.
It should be part of electrothermal, Tony. So, are you asking any new material property related to that?
Right.
Can't think of anything different, anything separately than for just the spice to have that back annotation for self-heating, especially.
We have power dissipation of components a few rows down already, right?
Yeah.
Yeah, so that's the input, isn't it? You get the power, and then you work out what effect that power is going to have on the.
Yeah. That's kind of that electrothermal thing. Like
on the thermal profile, yeah.
Yeah. Kind of feedback loop there.
Yeah, because the active devices are generating heat, and then there's other heat. So,
Yeah, and when you go to your 2 nanometer, it's really
We have Jen here. So Jen, last time I think we were not around. We're asking about maybe if possible to get some material test cases. Do you think that something possible that you're able to? I think some example that might be help as well to look into from a different angle, for the material information that might be needed to cover in this standard format.
Right now, I think this is a little bit outside the scope of what my team is doing. So we don't have input at this point.
So Zane, I think the other thing is maybe if you could reach out to somebody in the thermal group to see if they're interested in joining us for this discussion.
Okay.
And same with stress, for mechanical stress.
Okay, Tony, didn't Satish have a chance to talk to you about? So I know that we are focused on the bumps and the CDX part of it a little bit more. But I think this is probably come like in the future. I can double check with the thermo team, but I think that's kind of like the general.
Yeah, well, I know Satish is not specifically looking at this, but
Yeah.
I'm just looking for kind of I'd like to invite, some of the thermal and mechanical guys to the discussion.
Okay, I can check around.
Okay.
Mhm.
Yeah, I had the action to reach out to Satish, but we've been playing phone tag.
Sorry, what's your task again, Tony?
Well, I just delegated to Zane to invite a thermal
Okay.
and or mechanical stress engineer to the MDK meetings.
Right.
I had a question maybe for Andrew. Is mobility a derived parameter or a primary property of the material?
Mobility.
Yeah.
As in when you're looking
Electron
at the actual
mobility or hole
semiconductor.
mobility, charge carrier mobility for the material.
Yeah, that's an electrical property. I'm not sure James can speak to that, but I know stress will have an effect on the mobility.
Yeah, I didn't see it separately listed out, so that.
Yeah, I guess that's where the experts can add into that, because that's not something that that I've got experience with. So.
Yeah, that's probably something we could talk to our stress experts, or if Intel brings somebody.
Yes.
So I think that is an output. I don't know if it's an input to the simulation, to your stress simulations. Although I guess you do need I guess it's in the SPICE model. Yeah, I don't know. We're going to need an expert to answer that one.
Right.
But certainly temperature and stress do have an impact on mobility.
Right. So I'm just going to. Yeah, I think we have pretty good coverage on that. How about I think we somehow put that, decoupling capacitor materials here. I'm probably trying to expand it. We can, last time we agreed we should include this one, material for capacitors, right? The decoupling capacitors.
Say again, James.
Oh yeah, no, I'm just trying to say, like, we have that decoupling, like, capacitor materials we talked about last time previously that we should cover also, right? I just kind of put in here the placeholder.
John, any comments on
that? No, not here. I mean,
the decoupling is used for your AC power integrity analysis, right?
Yeah, correct. I mean, or even DC drop on the PI side. Yeah, it's not necessarily relevant that we have all the decap materials, but knowing the decap values is obviously critical. And then if there are supplied vendor models, that's the other
Yeah,
aspect of
yeah,
this.
yeah. I don't think we're trying to simulate the capacitance based on the materials, right?
Yep, correct.
Yeah. So we're assuming it's just we're going to be provided a model for those.
Yeah.
So yeah, I agree. I don't think that's so that's an additional input that's required for the simulation, but it's not really relevant to the material properties.
Correct.
Yeah.
Okay. So we're not covered, and then okay, that's a power, and then I saw the other places that listed the cap, the copper cap here. Here, okay, that's under testing.
I think
With
that's
the
really,
placement of the cap.
I mean, that's really a component.
Yeah, probably not.
But
It's
yeah,
only the placement.
yeah, I don't think we want to include the passive devices
Okay.
for material properties. I don't think that belongs on the list. Unless
Tony, how
somebody,
about the embedded passives like trench capacitors? It could be done at the FOWLP site also, right? Theoretically.
I mean, it is a model, right? There will be a model for that, but and it's probably part of the extraction problem too. It could either be, you know, you're instantiating a trench capacitor in an interposer, for example, and oftentimes the vendors will just provide a model for that trench capacitor.
I see.
But
Yeah.
in some cases, if they're kind of like parameterized, then you'd need extraction decks to do that. But I don't think that's part of the, you know, we're not getting into extraction decks in this scope in this.
In this scenario, yes, I agree.
I mean, I'm just, you know, talking
Normal
about
extraction
stuff.
decks don't need anything unique that's not here anyways, right?
Right,
So,
right.
yeah.
So I think, you know, that's covered under extractions or the models. You know, somehow you're either going to have a model from the vendor or there's extraction decks that, you know, the chiplet build designer is going to run an extraction and create a model for the analysis. But I don't think the analysis is going to be looking at, you know, those detailed materials of those passive components.
It goes to the same micro versus macro analysis.
Yeah. Now, same with MOS devices. And I don't know if we get into gas, Rudy, whether or not for thermal we need those material properties, or is that kind of similar thing where it's provided as an input?
It's usually provided as an input. Again.
Right. Yeah. Because you're going to characterize those devices, create a model, and then
Correct. That's the foundry usually
it-
provides that as the SHE model. They call it the self-heating effect or
Right.
reliability one. Yeah.
Right. And then when you put that in a package, you need all the other properties, but that's your heat generator, right? And and you're just simulating how that heat gets dissipated and distributed throughout the package.
So are we saying here, like, do we need material information in this model, like
For what?
for like the heat dissipation. You mentioned, I think were you talking about just the extraction pieces? So that's
No,
what
I'm saying that just in general, I think we're not really dealing with active devices or passive components from simulation. Those are just components, and it's
I
more
see.
the substrate materials, the interposer materials, you know, the lids and all the other structures that are in there that we need the material properties to do the analysis, but we're assuming those, you know, components that are, you know, used for the circuitry are pre-characterized.
I see. Okay, that's why they're not required, I think, for material informations.
Yeah, again, the scope here is for package levels. You know, if you're talking about device level, you know, designing the chiplet and going inside there, that we're not covering that here in this MDKs, right?
Right. Yeah. Makes sense.
Just like, you know, the micro level. You know, we really need to kind of be very careful about scope creep here. Otherwise, we're going to be creating a science project that'll go on for years.
Yeah. Yeah. Sounds like a fun project though. Like it's going to
Yeah, but we've got you know, we were trying to get this kind of firmed up by the end of the year, and just looking at the calendar, looks like we've probably only got one more meeting on the 14th, 2 weeks from today, and probably the 28th. A lot of people are going to be off that last week.
Right.
So I think, you know, we should try to get this kind of, you know, pretty solid by the next meeting. Do we think that's feasible in the next 2 weeks?
We'll try to. I think it depends on, I think, how much input we're getting. I think we're getting closer to that. I think we still need to go one more revision after this feedback. So I think Andrew, John, I think have some action. I think I help to fill some of this thing, and then Rudy can help. I think any tools that might have, and we have to see like you can bring additional, I think, resources. I think from Intel side. I think
Yeah, and I have a meeting tomorrow with Keysight, so I'm going to invite them to see if they're interested in participating with this.
Right. That would be helpful. Roger, I think if you talk to Lee Hong tomorrow, I think or the next few days, maybe you can sync up sometime next week or something, and see if there's something that you can help to review some of the mechanical materials here.
Yeah, sure.
Yeah. I mean, I think we've got a pretty, we've got a pretty clear scope now. We've got a way to record it. I think the best thing we can do maybe in the next 2 weeks is to reach out to all those experts within our companies, and just to validate, to add extra things in to validate it. Try not to get the scope creep too much. Make sure we're all clear, that this is what's included, this is what's not, and just get the people who actually do this to confirm that these are the right things that we should be recording. If we can get that in 2 weeks' time, that input, I think we'll be at least through this phase. I guess the next phase would be to start to look at the XML and define that.
Right. Yeah, that might be a little ambitious, but at least if we could get this team to get this pretty firmed up, then we can try to reach out and get additional members to join in. I think it's going to be hard for them to get them up to speed and look at it and give us feedback, and I think that's something we'll probably have to work on in January. But let's just do the best we can to get this in solid shape, cleaned up, and then we'll throw it out there and try to get the feedback from the experts to let us know if we're heading down or going in the right direction, or have any, major gaps.
Yeah, I think that makes sense. And I think so I think
Yeah, because once we start getting into the XML, then it's we want to make sure we've got a good solid starting point. We know it's not going to be final, but if we're making major structural changes, and then it's gonna get messy.
right. That makes sense. Yeah.
Okay. Andrew, anybody on your side who you think can help review this, within ANSYS?
Yeah. I mean, there's a couple of people in the electrical team, and we've got an electronics reliability team as well, so I can pass this by them.
Yeah, and Pratush, yeah, I'm going to be traveling next week, but maybe you could try to reach out to Andres and go through this with him.
Yep.
I think that would be a good start. He can cover a lot of the thermal and stress stuff.
And Jules, is this someone from the Siemens side or?
Yeah.
Okay.
I thought we had him invited. Is he on the invite list, David?
Maybe not for the rolling one.
Yeah, we should definitely add him. Let me just see. We got a pretty big distribution.
Very long.
Yeah, we need to clean up this list a little bit. I see some names that don't belong here and some missing names. And then
Tony, let me know any updates I need to make to the list. But to avoid confusion, please let me know which meeting exactly, 3DK, MDK, main CDX, and so on. Sometimes I get it wrong.
Yeah, so for the MDK, I'll just send you some quick feedback. I'll send you on that email, but there's one that we should add and one that we should remove. Now there's a couple here. All right, I'll provide you feedback on this list.
Okay, thanks.
Okay. And hopefully we'll get some additional folks added too.
Okay.
All right.
That sounds good. Yeah, I will follow with Mutu as well. I didn't see him joining, but I think last time he mentioned, I think he seemed a lot experience on the bonding properties, material properties. So we'll see if we can get hold of him again.
Who is that?
Mutu from the Western Digital.
Okay.
He was joined there, I think, in the couple meetings before. Yeah. Okay. I think we'll see if we can get hold of him by next time.
Okay.
Yeah, that sounds good. I think we're going to trying to follow with your expert for the review. Hopefully we can get a lot of input from next time that get closer to what Tony is trying to target for end of this year, right? And then after then we can early next year we can start looking at XML then. Any final feedback from anyone? Andrew?
No, I think it's fairly clear now. Yeah.
Okay, that's good, right? John, Pratt use?
All good here, James.
Okay.
All good. Just one question, James. So I'll review the sheet, material MDK Google Sheet with the team. And if we have to add anything to it, how do we follow a convention? Because it could get confusing, right? We probably just add as a comment, and so we know who has done it, right?
Yeah, I think you can add a comment. I think insert a comment. I think that's one way to do.
Right.
Or unless something is totally new, we can add that and then
We could put our name in the bracket who added the comment, right? Yeah.
Okay. Right. Or can use a color, different color when we are trying to do. But I think comment
It's
maybe
okay to go ahead and edit it ourselves.
Yes.
Okay. Yeah. Thanks.
Yeah, appreciate that. And yeah, Roger, anything from your end?
No, it's fine. It's fine.
Okay. Okay. Thanks. Yeah. And then David, like Tony, any final words from you guys?
No, this is good. This is very good stuff. I'm really excited. I don't think this kind of stuff has been captured anywhere in a kind of collaborative fashion like this.
Yeah, I think we dive in a lot of details, right? From different point of view, from material. I think that's really good. Yeah. All right. Tony, if no final words from you, I think we are good for today, and then we will, hopefully we get more expert, and then we will, get closer next meeting there to what we want to.
Yep. Okay.
Okay. Thanks, folks.
Yep.
Thanks, everybody.
Thanks.
Yeah. Thanks, everyone.
Thank you.
Yep. Bye-bye.
I can eat now. I can eat now. I'm ready. I said now.
We're right there. Hang on. Temporary. Yeah, I'm doing it in California. So I need a computer to work with. So just don't want my computer to time in. The fuck did that go? What? Hello? Okay, where's my zip drive? Hello? Hello? Myself. Can't find my zip drive. Where did it go? Oh, fuck me. Yeah, I lost my fucking zip drive. Oh, come on. Where the fuck did it go? Because if I knew where I put it, I would get it.
What color is it?
Blue.
Blue? Maybe Danielle moved it. Are your books here? Oh, Brookside dark chocolate. Hmm. Did you just pack it down?
Like 2 weeks ago. And I checked data on it on my PC. Now I can't see it.
It's not in your PC?
No, on the home computer.
Where would you plug it in?
Underneath here on the computer or on this or this or this.
Blue?
Blue.
I looked under there and said, why don't you use your light on your phone, see if it's under there? some reason. Not in your pockets, check.
There you go. Man, you're a fuckhead. You fucked me up. You were rushing me. Yeah, I'm losing it. I know that. It's not me. Fucking IT. Fucking me up. It's the IT department. Yeah.
Schedule a trip to Germany. What?